For question 16, express this fraction in the form of partial fractions. So before we express it in partial fraction, the first step is we're going to check whether this fraction is proper or improper. So you can see numerator here, this is a quadratic. For denominator, x squared, when it's times x, it will be result as a cubic polynomial. So a quadratic divided by a cubic polynomial, it will be in the proper fractions. So our first step, we double check. Yes, this is a proper fraction. So therefore, we proceed to second step, where our denominator, our divisor here, should be in the factorized form. So given our divisor here, you can see x squared minus 4 and x plus 2. We can see the quadratic here, it can be factorized completely, which is x minus 2, x plus 2. So we must make sure our divisor here is in the complete factorized form. So you can see we have three factors here, where the first factor is linear factor x minus 2. Meanwhile, the second factor and third factor, they are same. So these are repeating factors. Then only we proceed to express our fraction into a partial fractions. So we can see here, the fraction here will be split according to the factors. So we have a linear factors. It will be our first part of our partial fractions. And then when we have repeating concept, we have to apply repeating concept when we see our factor they are repeat each other. So our repeating concept will be the first factor we will write as x plus 2. For the repeating time, it will become x plus 2 squared. So that will be our step 3, which it is a split into the partial fraction according to the factors that we have. So involving linear factor and repeating factor. Then step number 4, we're going to determine what is going to put here, whether constant or linear. So when we have a denominator linear, so our numerator will be a constant. So same as here, we can see our denominator here is a linear factor. So our numerator will be a constant. So for this part, this is a repeating factors, but you can see our factor, this is a linear factor actually. So the numerator part is a constant. So that will be our step 4, determine our ABC. And then we continue for our step 5, we will come up an equation where we equal our numerator part. So how to equal our numerator part? We will times the a with the factors that it don't have. So you can see under a, the factor is x minus 2. So a will times x plus 2 square. For b, it has x plus 2. So the factor it don't have, it will be x minus 2. Another one x plus 2. Because x plus 2 is a repeating factor, it only have once. So we need to times another one. So for C, it will time with the x minus 2. So from here, we have to solve our ABC. So since we have 3 unknowns here, we have to let it 3 times in order to find out what is our unknown ABC. So we will let it using the roots. It will be easier for us to get our ABC directly. So our roots here, we can see our factor. Our roots here, we can let it x equals to 2. We can let it x equals to negative 2. And under another x, we can let it to be any numbers, let's say 0. So when we have x equals to 2, we substitute inside here. We will get 20. Then when we substitute 2 here, 2 times 2 plus 2 is 4. 4 squared will be 16a. And then when we substitute into x here, it will be 0. And then 2 here will be 0. So we can get our a directly to the answer of 2. So that is a benefit of us when we're using the x value which is selected from the roots. So now we repeat for the x equals to -2, substitute into the equation here. So when we substitute -2 here, we get 0, -2, 0, so -2, -4, c. Therefore, we find out our c is -4. So lastly, when we don't have any roots to be selected, we will use random numbers. So use a number that can easier us for calculate. So I choose for a value 0. Substitute into equation here, I get 4. And then whatever we already done here, we use back our a, we substitute and we use it. So this one 0 plus 2, 2 square become 4. And then our b haven't find it. So times it 0 minus 2, 0 plus 2, c is -4, 0 minus 2. So from here we find our b value. So our b value will be equals to 3. So after we find out our ABC here, last step, we need to substitute back into our fractions. Where A is 2, then B is 3, so positive 3, and then C is -4, so negative come out. So this is what we mean. We express a proper fractions into a partial fraction. Partial fraction means a fraction that will be a smaller part. One part of this from this fraction. It will be one part of from these fractions. So from here, what is very important when we're doing our partial fraction, our expression, that it will be very important. How we separate using the factors from the denominator and determine whether it is a constant or is a linear. So if our denominator is a linear, our numerator must be a constant. So this is considered linear factor. So up here will be a constant. So this is very important when we express it correctly. So if we express it wrongly, then everything here will be getting wrong. Then we build out our equation. We equal the numerator part. When we finding which factor that it don't have, we multiply, we build out an equation here. And we start letting by using let method to find out our A and B and C. So 3 unknown, we need to let 3 times. So that will be our concept. So after finding our ABC, we must express and substitute back into the fraction. So this is what we call partial fractions.